Okay. So thank you everyone for attending this session. We're going to be discussing Modin and doing a tutorial on Modin. First, I'd like to give a bit of an introduction on Modin and kind of give some updates for those who maybe haven't heard updates in a while, and give some thought to kind of how we see Modin fitting in the whole landscape of data science. So the idea of Modin, at the center of the ideas of Modin, are the data scientists, basically. So we choose to focus on the data scientist and the data scientist time as the metric that we optimize for. This may seem obvious, but optimizing for purely CPU performance doesn't necessarily provide the data scientists with more productivity. And I'll talk a little bit more about this later. But first, I kind of want to talk about the data science landscape and what things look like today. So some of you who have seen perhaps some of my other talks, this slide may be familiar. But in general, what I like to talk about on this slide is that there's this big rift between tools that work well at the larger scales and tools that work well at smaller scales. And we're starting to see this change, but we're still not there yet. We're still not at the point where you can use the same tools for small scale data, the same APIs for small scale data as you can for the large scale data. So the challenges on the small scale data tend to be scalability, but there are a lot of positives for the tools at the small scale. So for example, the tools at the small scale follow typical programming styles, and they feel very natural in languages like Python. They're also widely used in production at many companies, and the majority of college graduates already know how to use these tools. It doesn't really require special knowledge to learn how to use pandas, right? You don't have to have a specific major or a specific focus in distributed data science to do this. And so there's a larger talent pool for tools at this size. On the larger scale, we have a bunch of challenges related to usability. And these challenges tend to be, they tend to be around debugging and kind of needing to understand some lower level implementation details about the distributed computing environment that you're running in. So even things as low level as needing to understand partitioning and needing to know how many machines that you have access to. These can all be things that you kind of need to know in order to use some of these larger scale systems. And part of this is a byproduct of them being designed by people who are distributed systems people. They weren't really designed for the average data scientist. Average data scientist is typically a domain expert in some scientific field or some business area, and they know their data really well. What they aren't classically trained in is distributed systems. So that's kind of where the source of the rift ends up being. And what Modin does is Modin is effectively removing all of these challenges from the right, all these usability challenges. So you end up with tools that are usable and scalable at both ends of the spectrum. And so if we take a look at the kind of common, the common machine learning lifecycle in many companies looks very, very similar to this. So often you start out with pandas on a small data set, and you do some exploring and prototyping of that data set. And then you hand it off to a data engineer, or maybe you yourself as the data scientist would do some rewriting so that it can run on some test cluster. Sometimes it just goes straight into the production cluster, but often there's a smaller cluster in the middle. And even between the small cluster and the large cluster, there's still some rewriting that is involved a lot of times, because you have to manage some partitioning, like I said, or some worker orchestration. You have to do some changes. You can't just basically take the same notebook and then run it everywhere. But with Modin, you can. So with Modin, we really it's really evolving to becoming more of a data science platform. And we started with basically one simple idea, which is speeding up your pandas workflows by changing one line of code. So it's really, really easy to use. You just swap the import statement, and it's a drop-in replacement. It can be installed from PyPy. There's a new Intel channel that you can install Modin from, and you can also install it from Conda Forge. So to talk a little bit about the scalability issues, I'm going to kind of quickly talk about the problem here. So if we imagine this as an oversimplified view of a modern laptop, we say that modern laptops have many CPUs. And with pandas, you're really only getting one of your cores being utilized. This may not seem like a big issue, but with full utilization, you get basically maximum performance. And if you recall, Modin doesn't require any code changes from pandas. And maybe 3 cores isn't such a big deal, but if you have a data science workstation, which many data scientists do, this becomes much more evident. The performance gap is much, much higher because Modin ends up using all the CPUs on that. And it becomes even more drastic whenever you start talking about cluster and multi-machine. So in this view, pandas could really only use 1 core, and Modin can scale to basically as many machines as you have. On the API coverage side, there's been a huge amount of work that's gone in through a number of great contributors. Some of them are actually here with us today. But we've reached over 91% of the Pandas data frame API coverage and 88% of the series. And we'll look in the tutorials, we'll kind of walk through what happens if it's not covered, because it still works. There's just a process in which it converts to pandas and then does the operation and then converts back. But we'll go over that in the tutorials. But we see here also that a lot of the data ingestion / reading formats are supported, including Excel, which is relatively new. Read Excel is probably one of the longer ones. It can take like many minutes to read a single Excel file, a small one, like hundreds of megabytes. Can take about 10 minutes. But Modin can do basically a parallel read on that Excel file, and so yeah, and that's a relatively new feature too. So if you're coming back or you've been following the project for a while, you may know this or you may not. So with the remaining of this kind of short introduction, I kind of want to talk about the fundamental thought behind how we design Modin and what we kind of want to influence the entire data science tooling community to move towards. And that is prioritizing the data scientist time. Basically using the data scientist time as the metric that we optimize for. And so if we take a look at how we think about things, scaling data science is about scaling data scientists, but unfortunately there's not really a cloud for spinning up more data scientists. You can't just go and add another data scientist if you want to gain more insights. It's not that easy. Hiring data scientists is not as easy as spinning up a cloud resource. So what we want to do is basically optimize for the fixed resource that is data scientists and their time, and do that at the cost of more compute, essentially. So if we look at how data science tools have kind of been operating lately, before we've kind of started this movement, what they've been doing is adding more requirements or new semantics or new APIs. They've been limiting what you can do in terms of like data frame operations that you would traditionally do in pandas. A lot of this has been limiting the data scientist's productivity, and they do this in the interest of getting more machine time performance. Basically, they want to show better plots, and they do this because it's an easy metric to optimize for, right? It's really easy to say my CPU time is faster than your CPU time. It's a lot harder to say my data scientist works faster than your data scientist. But we're trying to change that. And one of the problems here is that we're sacrificing the data scientist productivity, and we're doing it in the interest of machine time, which is totally backwards. We should really be sacrificing machine time in the interest of data science productivity if we absolutely had to. But Modin is really removing all of these requirements. These requirements don't exist in Modin. It's basically just use pandas as you normally would, and you automatically get better performance. So in this way, we're improving the data scientist productivity because there's no extra effort on their part. And we're improving the machine time because we're leveraging as many of the cores as they have available to them. So I've written a blog post that kind of details a bit of our thoughts. Well, they're my thoughts. A bit of my thoughts on this problem and about how kind of we're building tools that are making sure that data scientists just never really get back the productivity that they've lost in having to take on all these new responsibilities. So feel free to take a look at this. One of the insights from the blog post is that it would take 200 years to recoup the time it costs to learning a new tool, even if the tool is 10x faster. And 10x is kind of the barrier in systems for saying that a tool has like made dramatic improvements. So happy to hear your thoughts on this. And with that, I'll close and we can kind of do the start the tutorial walkthrough. Modin is just over 2 years old, and it's been open source its entire life. There wasn't ever a time where there was a closed source version of Modin, or that it was only available to a small number of people. It's really been growing extremely fast for an academic project, and we're really excited about that. We would love for you to join us. Let us know what you're doing with it, what you're using it for, how it's working for you. It's being used in a lot of locations, a lot of companies and organizations, and yeah. So with that, we're going to start the tutorial session now. That's going to be done off of the GitHub. So I'm gonna stop sharing for a moment, and if you have any questions, feel free to just put them there in the Slack. I'm happy to answer any questions there. Okay. The Zoom window disappeared on me. I'm sorry. Okay, I've got it. Cool. All right. So with that, let's go ahead and I'll share my entire screen here. Okay. So for those of you who are following along, so some people did come in a little bit late. I'll just briefly mention to them on the Slack. There is I made a comment here about some ways to kind of get prepared. The slides are listed here. You should be able to see my screen, I believe. The slides are listed here. And then we need a terminal window, and we're navigating to the GitHub page. So right now I'm going to start assuming that you've already navigated to the GitHub page. And these are great questions. I will answer them shortly, but let's go ahead and kick off the tutorial part, and then during the more individual parts of it, I'll start answering the questions, because these are good questions that are commonly pop up. So good. So assuming you're here on the GitHub, the tutorials are located under examples tutorial. Now, if you have your terminal window open, you can just do a git clone of this address here, the HTTPS one. This will clone directly into Modin. This clones the entire project. Yes, it also includes all of the tutorials and examples that we have. We're going to be spending our entire time in this tutorial section. So once you have that cloned, assuming you have that cloned, let's go ahead and cd into Modin. And then we're going to start a virtual environment, just hopefully to avoid any environment clashes or environment issues. If you haven't installed virtual env, you would do pip install virtual env here. So I should already have it here. Yes, I do. Okay. So once you have virtual env installed, virtual env, we'll just call this Modin tutorial. Seems like a decent name. And we'll just start it. Okay. So now we need to activate it. And that is done with source Modin tutorial slash bin slash activate. I'm doing this live, by the way, completely live without like copy and paste. So this will be very real. Okay, so now you see here, if you look on my, maybe this isn't visible, so I'll make this font size larger. Okay. Okay, so we see here that we're in the Modin tutorial, and I also have a conda environment running, but that's not super important. So we're going through virtual env just to avoid any conda issues as well. Okay, cool. So I'll go ahead and assume that you got here. This is some pretty typical stuff, so I don't want to spend too much time on this. If you have any problems, please just DM me in the Slack, and I'll help you walk through it once we get to a stopping point for where people can start working on their own. So from here, the tutorials are under Modin examples tutorial. So if we take a look here, we can just we should just cd into examples and then tutorial, assuming that you were in the Modin project base. And from here, we have a requirements.txt. So we'll just pip install -r requirements.txt. Okay. And this will grab all of the requirements, hopefully all of the requirements. I've tested this, but you never know with Python environments. Sometimes there are issues. So if you do run into issues, always feel free to let me know here. Okay, nobody yet seems to be having too many issues. Okay. And okay, so this is all installed. And then once you have it installed, sorry, my Jupyter Lab. We'll be running this out of Jupyter Lab. Okay. And once you've run Jupyter Lab, then you should see a screen similar to this. And I'll go ahead and pause here. And yes, so so there's a requirements.txt that's in the tutorial directory. Yes. So what I did was from the project root, I did cd examples/tutorial, and then that's where the requirements.txt lives. So I just went ahead and pip install -r for that requirements.txt. I'll go ahead and put it here in the Slack as a response to your question here. So this is assuming you've already changed directories into the Modin project root. Okay. Okay, and then so for those of you who are here and ready to get started, I'll go ahead and kick you off. So over here on the left, the navigation, you just want to do tutorial notebooks and then introduction. These are the 3 tutorials that we're going to be going over, and they shouldn't really take you terribly long. There's a lot more here that you can do. I have some cluster tutorial as well if you get far enough. That does start a cluster for you, so be aware and make sure that you read the details closely. But here, these 3 notebooks are what we're going to be focusing on for the introduction. So I'm going to go ahead and stop sharing my screen for a moment and help the people who haven't quite got here yet. Yeah, feel free to just kind of go at your own pace for a moment and start with exercise 1 whenever you're ready. Okay. Oh, shoot. There have been people waiting. I'm so sorry. Okay. All right, so everybody should be in the room now. Okay, to start Jupyter Lab, you just type Jupyter Lab from your terminal. Okay. Okay, and for those of you who came in a little bit late, or who I have not, who I kind of went a little bit past, or went a little bit too fast for, excuse me. Everything is being done off of the main repo. We have an examples/tutorials here directory. So under the examples directory, there's a tutorial directory, and here we have some tutorial notebooks. This is a self-contained tutorial. All the requirements are here. Yes. Okay. All right. So yes, good point. Okay. I'm gonna go ahead and share my screen again. So okay. So I'll open a Sublime Text window and basically just use this as the separate window for the commands. So the first thing that we did was git clone here. And cd into Modin, and then pip install virtual env. And then we started a virtual env. This is all done in the terminal window. And then we activated our virtual env. This line will be slightly different for Windows. But I think Windows people will know the difference. And if you don't, let me know. Okay. So this here is what you... Okay. Is anyone stuck? Okay. Okay, yeah, let me go ahead and start answering some questions, and feel free to type them in here. These are all great questions. So for those of you who are here at the tutorial notebooks, we're starting with introduction and exercise 1, and it should look something like this. It's self-contained, so feel free to read and follow along. There's plenty of space here to, or there should be plenty of instructions here, but if you get lost, please let me know. Okay. All right, so going through the questions here. Can I talk a little about the difference between Dask and Modin? Yes, this is good. So there's also an issue here that I've pinned that I will post here. I'll give some high level I'll give a high level discussion to listen to while you're working through the tutorial. But at a high level, there are API differences, there are architectural differences, and then there are I think aims differences or goals of the project. So Dask covers I think 40% of the Pandas API, or maybe 50% of the Pandas API. They don't support multi-index, which I think is one of the big reasons why people don't or one of the big asks that people have had from Dask. In general, though, Dask's goal has not been to support the entire Pandas API. It's basically to support the Pandas API that can be kind of parallelized simply with row partitioning, basically, and using more traditional distributed computing techniques, I would say. So architecturally, Modin and Dask are quite different. Modin can run on Dask's execution engine. It does not use Dask data frame. We kind of sit in the same place as Dask data frame would. And we did this because the difference in code in the Ray backend and the Ray backend and the Dask backend is about 600 lines of code or something like that. It's very, very little in terms of how much code. I think Modin is probably 60,000 lines of code or something like that now. So a very, very small amount of code is gone to the difference between Dask and Ray. And that's because of the way that we've architected things. We have basically architected Modin such that you can bring your own execution engine and kind of implement it underneath to gain the same benefits of having the Pandas API, but with a lot of our internal optimizations that we've implemented. So yeah, I mean, I hope that this, there's much further reading here. I think this is still fairly short, so I'm happy to go into further detail if there's any more questions about that, or any any more questions, or if you'd like me to expand on anything. Modin on Windows, yes. So Modin on Windows uses Dask, can use Dask and Ray. Ray actually, that was a problem probably a year ago or a year and a half ago. I think a year and a half ago it was a problem. Modin didn't run on. But ever since we implemented Dask support, Dask Compute Engine support, we've been able to run on Windows, and now Ray can run on Windows. So yes, we can run on Windows with either Dask or Ray. XLSB extension, good question. So I don't actually know. So we've focused on I always get these mixed up. XLSX, the standard format. The approach that we use internally should work on XLSB. So my suggestion is let's try it and let's see. And if it doesn't work, let's fix it, because the approach that we've implemented is easily extendable. So okay, let's make sure nobody's running into issues. Oh, sorry. Yes, here's the list of commands. Okay. Using Spark. You all are seeing my Slack too, but okay. Some of these are questions that I will get to in FIFO order here. Okay. Sorry, I'll move this down. Okay, requirements.txt is failing here. Oh, Python 2.7, yes. So you need Python 3.6 or above, or Python 3. I think to be safe, it's 3.6, but I think there's a 3.5 point something. I don't remember exactly. Oh, 3.6.1. Okay, yeah. So if you need Python 3, you can download that from Anaconda. That's probably the easiest way to get it. 3.6 or above. I think it'll probably be 3.8 or 3.9. I'll post the link here. Okay, I'm going to temporarily stop sharing and then reshare the one window here. Okay, a timeout issue. Yeah, that looks like Ray is failing to initialize. Let me go back to sharing my whole screen here. Okay. Here's this again. Is anybody having any issues so far? Okay. So this is a good question. Can Modin be used with Tune? Not currently. So I'm working with the Ray team on this. Modin does use the Ray object store when Ray is the execution engine. And we're basically working with the Ray team to kind of come up with a good way of a good way of basically exposing some of the Modin internals like partitioning and things so that they can be consumed by these other libraries. And that's something that we're planning on working on soon. Okay, performance compared to Spark. So, okay, so performance compared to Spark. So this is something that I would, so I would, so in my personal testing, Modin has been faster than Spark. I would encourage you to try it for yourself, or to try to execute these things for yourself and not to take my word for it. But in my testing, Modin has been faster than Spark. Okay. Okay, so the timeout error, I've pinged someone from the Ray team to kind of help, hopefully that. Okay, from the Modin docs, it looks like it may use Dask as a backend. If so, are there any caveats about the coverage of the Pandas API? So I'm not totally sure what you mean about caveats about the coverage of the Pandas API. Dask, we use Dask's execution engine. We don't use Dask's data frame, and that's because we took a very strict view of what a data frame is. So part of my PhD work has been in like formalizing the data frame so that we can start to optimize it in basically in ways that give us better performance without sacrificing capabilities. And what Dask did with their data frame is they basically sacrificed capabilities in the interest of performance. And that to me seems backwards, because what we really want to do, and this gets to my talk, we want to empower data scientists and make data scientists the more performant system, if you will. We want to make data scientists more productive. And so I'm not totally sure what you mean about caveats about the coverage of the Pandas API. Maybe you can expand on that, but yeah, I hope I answered your question. Yeah, feel free to add another one if I didn't. Does Modin support distributed training of ML models such as Dask and XGBoost? Yes, so we have some early preliminary support for XGBoost in an experimental branch that I've been working on. We are, performance has been great so far. We're doing a lot of testing to make sure that it's ready for experimental use. But yes, we do have preliminary support for XGBoost in the pipeline, and already have a working prototype of distributed training. Yes. Okay. All right. Any other questions? These tutorials, by the way, are intended to be very straightforward and simple. So if you find them to be simple, that's by design. Modin is intended to be simple to use. So yes. Okay, so what I'm going to do with this is I'm going to paste it here as a pinned comment. Slack. Into channel. So if you need to, I probably should have done this in the beginning so that you can copy and paste it, but that's my fault. All right. Okay, exercise 2 and exercise 3, which exercise 3 gives some advanced usage and how to make some custom functions in Modin. Okay. I'll go ahead and answer these in text as well, because I think that's valuable. Modin is 880.32x faster with 4 cores. Okay. Did it print? We do have some optimizations in place that would explain some of this performance, but 800x seems a bit. I don't think I get that. It does take time to read from this. Modin isn't lazy, so that is actually executing. So A certificate error. Okay. Another interesting question. Good. Is it possible to run Modin on NVIDIA GPUs and take advantage of GPU memory for data frame processing? We have a collaboration in process to enable this, yes. So in general, GPU data frames are like Modin is architected to basically take advantage of all hardware that's available. So um, as much as uh, Rapids, the Rapids team tends to uh, talk about GPUs as if they're the only processing unit on the entire machine. CPUs actually shouldn't be idle at the same time. So, what's really exciting to me and to our collaborators at Georgia Tech is that um, we we're excited about this idea of a hybrid model where you can basically take advantage of whatever processing units you have available and automatically provision them. The user doesn't need to know that there's an NVIDIA GPU on a machine. They don't need to know that there's a you know uh, whatever processing unit, CPU, GPU, XPU, etc. So um, the idea is basically that Modin will use what is available, and if you want to limit Modin, then you're welcome to. But um, most data scientists will want to use as many resources as possible to get to an answer as fast as possible. So good question. I'll answer in text here as well. there are some fs spec issues. You can just pip install -U fs spec. That'll fix it. Okay. Any other questions about Modin in general? These are great questions, by the way, about roadmap and about our thoughts. We're seeing a kind of a shift in the way that people are starting to think about data science tooling and the impact that we've kind of had on the community. It's been pretty inspiring to see. So I'm happy to talk more about that and talk a bit more about any other questions you might have. Okay, Jacob asks, I think Spark also provides some tools / library to convert the pandas data frame to distributed data frame in Spark. So Modin serves the same purpose to parallelize the data frame for better performance. Partially, yes. But Modin and Spark are very different in how they handle this. So Modin works with your existing code. Modin is designed to work with your existing code and frameworks. It integrates with scikit-learn, just like Pandas does, and doesn't really. Modin isn't trying to own an entire ecosystem, whereas Spark is more about rethinking the entire ecosystem and trying to fit everything into this MapReduce model. So part of my research into data frames has basically been kind of uh, showing the fact that data frames just don't fully fit the MapReduce model well. So there are a lot of things that uh, Spark just won't be able to do efficiently. And a lot of that has to do with it being a kind of bulk synchronous processing slash falling under that MapReduce model, which has been around for several decades now, or a couple decades at least. So Modin does parallelize the data frame for better performance, but Modin's goal is to uh, basically enable you to use the same notebook for every scale, whereas Spark is heavily focused on and really only focused at the large scale. Um, so the difference is that in general with pandas, when you're using Spark, you're doing some workload like this where you end up doing rewrites every single time you need to move between clusters, and it's very cumbersome and human capital intensive. So this human capital we value in Modin, we value a lot higher than we do any other metric. So we're focused on effectively enabling data scientists to use the same notebook at all scales. So that's what I would say the biggest difference between Spark is. It is a distributed data frame. Spark's data frame is not a real data frame. If you ask me, I do my research on data frames, so I'm very opinionated about this, and I've written about it a bit. Happy to share any of those materials, but um, in general, Modin is basically optimizing for a completely different metric than Spark is, I think. But it does parallelize and distribute the data frame for better performance and for better scalability. So it's a great question about Spark. And one of the, so I recently wrote about this, and I think that this might be really interesting to you, Jacob, and to others. So this kind of blog post kind of gets at that idea, at the ideas behind Modin and how those ideas are a bit different than the ideas behind Spark. Okay. Final number for apply in tutorial 2. Let's see. This is on 16 cores, I believe. So 16 cores, I got 400x. So this is what I've got for the apply. $1,000. But so Modin has much more efficient storage for data in memory. A lot of these things are kind of too low level to really get into for an introductory tutorial, but I'm happy to talk more about this in you know in detail later about how Modin stores data and how data is looped over. So okay. Yes, Jacob, exactly. So so Modin isn't trying to force everybody into a completely new ecosystem. Um, totally agree. Okay. So I need to double check when. Let's see. So we have about 8 minutes left. Are there any other questions for exercise 3? What type is dataframe.mad? Dataframe.mad. Oh yes, it's a reduction function. Yes. So it should be. So we have other types of custom functions internally, and this is kind of showing some advanced way of writing some custom functions, but it also kind of gets you familiar with how most of the difficulties of writing distributed algorithms are abstracted away, so that you can, even as a developer, you can just focus on the things that matter to you, which is what type of communication pattern you need, and then how to implement the kernels as fast as possible, basically. So yes, mad is also a reduction function. I will. All right, so we've just a few minutes left. I'm going to um, just mention some closing remarks here. I will reshare this link in the Slack here. And I want to thank you all for coming to this session. And if you have any questions, any other further questions, feel free to email me or reach out to me over Slack. Happy to talk about what we're doing and kind of where we see Modin heading in the future. Really appreciate your time, and thank you again. All the links for everything that you need should be here in this presentation. So yeah, feel free to again, feel free to reach out, email me, or Slack me with any questions. Just hoping a couple more people who've. And again, this is not something that I'm hosting. This is something that you can do at any time. Really, these tutorials are here for. They're in the repo. They're here for you to share and to show your friends and colleagues. So. So yeah, thank you so much for coming. The session is ending shortly. And the next session is lunch and office hours with Jan Stoika. And I think you can find the call details in the general Slack chat. Okay, thank you all. I'm going to end the session now. Feel free to reach out over Slack. Thank you.